My name is Nick Shadran, and I'm going to be talking about NGINX Unit, the application server part, the backend of the systems. And Kevin Jones will talk about how to bring Unit closer to the users, closer to the production level traffic with the NGINX load balance and reverse proxy. Now I have a quick question for you. Who has already seen a demo or used or had some knowledge about NGINX Unit software? All right, I can see some hands up. If you are on the live stream, show us a thumbs up. We can see you through the laptop camera. No, I'm kidding. I actually don't know if we can see you.
We'll just assume it was 200 thumbs up.
Yes, absolutely. Sounds good. All right, so I have this couple of fun diagrams for you. And I did not bring any slides. This is the only graphics we're going to see. Then we're just going to jump into command line and have a lot of fun with the software itself. So the first diagram is showing the NGINX Unit in the most simplistic configuration. What we're going to do is we're going to take the API of the application server itself and bring up a very simple PHP application, which is also the most popular application in the world, WordPress. And we're going to expose that application through port 80. Very simple, just the PHP scripts, just the minimal configuration of what we can do. And in the second part of this demo, we're going to bring it to a more productive kind of sense. We're going to look at a couple of different application level routes. We're going to serve some static files along with the result of the PHP script execution. And then we're going to expose that on port 443 with SSL, and we'll build up a little redirect from port 80. So basically, our goal for the next 15 or 20 minutes is to have a fully running WordPress site without the use of NGINX, without the use of Apache, and without the use of any other technologies like PHP, FPM, or IIS, or other things. We're just going to do it directly and simply and fully into NGINX Unit. And we're only going to use the API of NGINX Unit to do that. And I'm not talking about any special scripts are going to change the config files. We're going to just dump JSON data into the API and see how that will work. All right. So let me switch to the command line. Can you see that well, or should I zoom it in a little bit? Good? All right. So what I have here is a very simple system, and I'm just going to show you that we don't have NGINX process running on that. We just have somebody editing the config files. That's probably Kevin preparing his part of the demo. And we can see a process here that's running called Unit. And Unit main process has a couple of other additional processes running in the system. There is the controller process that deals with the automation and API access, and there is the router process that deals with the production traffic. So next thing that we're going to do is we're going to look at which ports are currently open. And we can see that our Unit API port is open here on 8432. So all we're going to do right now is access that API. And we're going to see that the result of that API execution is very simple. There is absolutely no config. Everything's empty. Everything's clean. The system is not ready to do anything. And that actually shows here that we're refreshing our page and nothing is running. OK, so one thing I want to note right now is if you're running a system like that and your API is exposed on a port, make sure it's protected appropriately. So this is a demo system. I don't care much about its security. In any production level, there must be levels and layers of different things covering this kind of security access. All right. Now let's go to our directory where we have lots of different files. And we have a couple of things. We have WordPress already downloaded, and the initial installation of WordPress has already been finished in the directory WordPress here. And I built a couple of JSON payloads right here in this directory. So what I'm going to do here, I'm going to walk you through the most minimal configuration of NGINX Unit to run a PHP script. And that's going to be this one, unit start JSON. All right, let me turn off syntax so we can see that a little bit better on the screen. Our projector in the room is a little bit dark. All right, so we have a couple of things. We have a listener configured on port 8790, and that listener has a parameter pass, which passes all the requests from that listener into the application called WP. The application WP has a type PHP, very simple, and it points us into a directory where WordPress is configured. There is nothing else for the most minimal installation of that. So what we're going to do now, we're going to use our curl tool, but instead of getting the config, we're going to put the config in, and that's going to that's how we're going to create the put request. And as the data into that put request is going to be the contents of this file, start.json, and we're going to put that into our API port /config. Here we go, configuration done. Now if we look at our processes, we can see that now Unit has a WP application running. If we look at our netstat, netstat L4NP, we can see that our port 8790 right here is now owned by the Unit's router process. So something should actually respond on that port. Let's take a look. Let's do curl -i into that port 8790. And here we go. We can see that we have some WordPress responding to this. It's running with the server Unit. And the most basic configuration, the most simple PHP script is running right here. Our system likes to redirect us somewhere else into a different location, but we're not gonna care about that. We're gonna configure just the next level of this whole thing. And for that, I will show you the full configuration file with lots of different things in it. Okay, so the full configuration file has the next very important object, and that object is called routes. The routes object defines how the traffic is going to be routed across multiple applications, file share directories, or basically anywhere around that, depending on the rules that we define. In this particular case, we defined a very simple rule that everything that ends with .php and everything that ends with a slash, which is basically a directory listing or a slash directory, is going to be routed into the application WP, just very similarly as we could see in the previous example. And we have another match rule that takes all of the static files and routes those static files not into the application, but into a directory itself. All right. The rest is a little bit more complicated here, but not too much complicated. We have the very similar, we have built another application called redirect, and we put that thing on port 80. And on port 443, we pass all of the requests into the routes object that we just created. All right, sounds good. And we still left our port 8790 for debug and other purposes right here. Okay, our applications are extremely simple to set up. WordPress application still has 2 lines of config, and our redirect application has another parameter called script. That's the one that puts any kind of request coming on port 80 into our special index.php script, routing that the way that we like. Okay, so that's our full Unit configuration. However, there is another object that is referenced here, and that's the object here in the TLS thing. There is the certificate that we defined in this configuration. But the thing is, when we looked at that, the configuration of Unit was absolutely simple. There is no reference to specific files. There is no reference to any certificate storage or anything like that. So what I'm going to do here is I'm going to put the actual certificate data directly into Unit's API, into the certificates storage. And I generated the proper certificate with Let's Encrypt. It's going to be our full chain with the key file. And the way I'm going to do that, I'm just going to dump it directly into our API. That's going to be data binary command for curl. That's going to be the file name, and our API endpoint is going to be a tiny bit different. It's going to be /certificates, and I'm going to give it a name, nfd.nginxlab.net. So basically, at this point, our certificate, the file, got loaded into our unit configuration. Let's check if we can actually see that. If we look into our configuration now, we can see that certificate got uploaded. All the data about the whole certificate chain is now known by unit. And now we can reference that certificate in the rest of our configuration. You still following? I'm going pretty fast. We don't have much time here. All right. So we got it there. And now I'm going to take that, that full configuration and dump the full configuration into unit's config object. And now at this point, we should see that in our netstat command, we now see that port 80 is owned by unit router, just the same as port 443. Let's check if we can see that here. Oh, yeah, we got something. -I, we get this, the simple redirect from HTTP to HTTPS working right here. And that's my script redirecting us there. So it means that if I use my HTTP endpoint in the actual web browser, it's going to redirect me into HTTPS. And let's see what happens here. All right, WordPress working. How long did it take?
Oh, world.
About 10 to 15 minutes. OK, that's cool. But the problem here, if we look a little bit closer, well, we can see that we only have one application process. This machine is a little bit more capable than running just one PHP process. Let's scale it up a little bit. But before we're going to scale it up, let's check what kind of load this machine can actually take. What I'm going to do is I'm going to look at, I'm going to take our AB Apache Bench test, and I'm going to run it for 10 seconds just to see what's our reference load, how quickly that WordPress is actually responding on this machine. And what I'm saying is just one simple process of PHP. So we can see that we're getting about 60-something requests per second from that machine. That's actually pretty good for just one process. That's pretty fast. But the thing is, when we look at our number of available cores, which is 2, it makes sense to ramp up the number of processes. And I'm not going to change the configuration files. What I'm going to do here, I'm just going to talk to the API and change that dynamically within the system without touching any of the files at all. And the endpoint for that is going to be our API 8432, and it's living in config applications. Remember our application/WP, that thing had only a couple of lines of configuration. What we need to do is we need to add the object called processes, and that one doesn't exist right now. What we're going to do is we're going to do our put request and put the data, which is literally, let's say, number 4, into the application processes. Let's see if that worked. Immediately, we can see that we have now 4 application processes of WordPress, and we didn't touch an application file or anything like that. So if I look at our application configuration, we can see that processes 4 got applied dynamically right after our request. OK, so the fun part about it, let's do our benchmark test again for those few seconds. Since we only have about 2 virtual CPUs, we shouldn't see an increase 4 times. We just don't have the processor capacity here. But we can see that our number of requests per second rose up about 1.5, which is a reasonable number for that kind of machine. We're starting to saturate the processors appropriately just by ramping up the number of PHP processes in the system correctly. So at this point, the machine responds on port 443. The machine is working with the proper SSL certificate, which is absolutely live. And if you have that URL in front of you, you can try it from your machine as well. It's what we configured right now. But another thing is, what I want to do next, I want to hand it off to Kevin. And before I do that, before we get Kevin here, by the way, where is Kevin? Oh, you're right here. Cool. We didn't lose you. So before I do that, I'm going to talk through the things that are currently not configured and what we need to do here. So the thing is, NGINX Unit is the application server and the web server for the file management, for serving the files. And NGINX in front of it can do a lot of other things. It can perform things like cache and load balancing. There might be ingress controls, application firewalls, security things, and plenty of things that Kevin will show us. So since Kevin is going to be showing the NGINX configuration on that same machine, what I need to do is I need to actually delete those listeners to free up the ports for Kevin to use. And that's going to be as simple for us as sending the delete request to the appropriate API endpoint. And in that sense, that were our listener/those numbers, listener/numbers API endpoints. So I'm going to send that request right here, 127.18432 listeners, and we had a listener called port 80. Oh, hold on. It's living in config/listeners, and I have to backslash the star. Okay, so we deleted the port 80 listener right here, and we deleted the port 443 listener right here. So if I refresh my page, now it's not able to connect. And I'm going to do netstat L4 np just to see that our configuration is freed up. So basically what I showed you right here is how quickly we can configure a running website with a simple PHP application. We can do that with a variety of different languages like Python, Perl, Go, JavaScript. There is a bunch of them in the list that we support. But the main idea was not to touch the config files and reload the services, but rather push the configuration data directly into the guts of the software, directly into that binary running on that same machine. And the changes that were performed, they were not restarting things, not reloading things. They were doing the direct in-memory reconfiguration of the routing and direct changes to the live system. So while Kevin is getting here towards the stage, I want to take all of the questions while he's plugging in his laptop and getting ready to show his part of this WordPress configuration. Go ahead.
I had a quick question. Unlike debugging and log, since you don't have a traditional web service front end, how do you actually?
That's a very nice question about the debugging of the system. So first, if we send something really bad, we receive the things as the error responses right there. For example, if I send a literal value somewhere, we received the immediate response from the API itself if something is very clear. When something's happening to the application itself, the actual unit process, it has a log file that dumps data into the file system, traditionally like as any other service in the system. So if we do tail our var log unit.log, we'll see some of our SSL browser is not liking something or some other errors. They will still be dumped into a log.
Okay, can you specify different ones? So if you're running WordPress on one and then you're doing something else, you can...
So currently, in addition to that, Unit has a concept of access log, where not only the errors, but the access functionality is going to be recorded. Currently, we can only do that for the whole system in that one same file. But this is a good question, and it's somewhere on the list of improvements. I just don't know exactly where it fits on the roadmap.
So where would you be? I mean, where would you guys position this versus, NGINX, running as a web server? Because NGINX web server didn't have a high amount of overhead in the first place. So you're stripping out some overhead, but what would you say the main purpose of this versus?
The main purpose of using Unit, it's consistency. So it's not just the file serving feature. Well, we all know most of the internet is still cat pictures. It's still static files running somewhere. But there is also scripts. There is also things written in different languages. And we're not taking NGINX out of the picture. Quite the opposite. Kevin will show how NGINX can be used together with that. We're basically giving you the consistent level of operation of whatever your application is. That being a Ruby app, a Perl, Python app, PHP, or basically whatever you like. Your operation of the app, you're just going to be changing the type in the API and dumping a different workload for a different type of app. And also, this is designed for highly scalable, frequently changing workloads and some places and some environments where you're building something from scratch, when you're ready to apply your own scripts, your own methods of how you're going to manage all of those things. But if your operation is pretty static, if nothing's changing in your web servers, or you rather be restarting them the way you like, you can use the conventional methods of doing that. It's just going to raise some levels of complexity and bring some inconsistencies in how the configuration files for each type of the software is managed.
Like private cloud lambdas. I mean,
you could think of that. Yeah, that's it's similar in that sense.